Okay, this is a pretty lengthy one. I want someone to double check. Um, Please attempt to do this problem on your own before you try to get the answers from me. Anyways, so this question, a spacecraft needs to orbit planet X at a distance from the surface of 14,000 kilometers. So this is 14,000 kilometers away from the surface. If the radius of the planet is 7,000 kilometers and the orbital period is 15 hours, what is the acceleration due to gravity? So I went ahead and let's try to see if you can follow along. So I went ahead and said that force is equal to this gravitational constant times little m times big M divided by radius, or the distance, squared. So coming over here, I'm finding the centripetal acceleration of the spacecraft, and I went ahead and just took out the mass of the spacecraft, and so the centripetal acceleration of the spacecraft is equal to this gravitational constant times mass of the planet times divided by the distance squared. This distance right here is, don't forget, it's the distance from the surface of the planet plus the radius of planet X. So more to come on that later on. Coming over here, you have acceleration is equal to velocity squared divided by radius. But we also know we have this secret little tool. Velocity is equal to omega times the radius. That's for the radial velocity. So we come over here, we're like, okay, omega is equal to 1 revolution per 15 hours. And then you factor that out to some type of revolution per second. Then you square it like this right here. But remember, just don't forget, acceleration is equal to v squared divided by r. V is equal to that. So you square this. So you have w squared, r squared, divided by r. That's that. So it comes out to acceleration. Centripetal acceleration is equal to omega squared times the radius. And I realized that this could be correct, yeah. I'm not sure if I messed up here, but I think I kept this in kilometers, which may have affected my answer later on. So I got this type of revolutions per second, square it, get this, and I should convert this to meters, and I should get 388.89 meters per second squared. So now coming back around full circle, no pun intended, come over here, same thing. Now we got this, we figured this acceleration out. This is what we got. And now let's just go back to the original equation. We have this is equal to this, and we're talking about the spacecraft. But now we don't have to worry about mass. We have this, we know g, and then now we're trying to figure out big M. We rearrange and we say big M, the mass of the planet, is equal to this. We have all of those. So now we say that mass of the planet is equal to this right here, 1.2215 times 10 to the 20 kilograms. So now we come around, we're like, okay, now assume a simple problem finding acceleration due to gravity on Earth. So I don't know if you guys remember that problem in class. We're like, oh, there's a person on the surface of the planet, and then you're just like, oh, it's negligible, right? Like the center of mass is the belly button, and the belly button is like negligible from the surface of the Earth. So it's just like, oh, Go ahead and assume that's just the radiation, or not the radiation, the radius. Assume the original radius of the Earth. I don't know if you guys remember that, but I do. Anyways, so now we're saying acceleration on the surface of the Earth is equal to this gravitational constant, which everybody knows, times mass of the planet, and now divide just simply by the radius. And I did convert this to meters. I did 7,000 times 1,000, and then I squared it, and I got a super small number. I don't know if it's right. I'm tired of doing this problem. I heard that there might be a simpler way. I may have just went overboard, but does anybody else get this? Let me know, comment, do not subscribe, and press like if you want. Thank you. Bye.